Hello and welcome back to Business Analytics. This is Hari Rajagopalan, and I will continue the lecture for this session in forecasting. So we finished descriptive analytics and we are kind of squarely in predictive analytics. And we have finished regression, we've finished data mining, and we're really going to start talking about how are we going to predict the future. And this is called forecasting, and we're going to talk about how we're going to do forecasting starting from this lecture. So what is forecasting, and more specifically, what is time series forecasting? And that's what we're going to really look at in this lecture. Here we're going to track characteristics of a process at regular time intervals. And really we're going to look at how does this metric change over time. And this metric could be your demand data, it could be temperature, it could be the sales, it could be stock values. So, but we're looking at time as your basic predictor here. So time series is used in multiple areas. Here are a whole bunch of them, business, economics, social sciences, medicine. You can use it anywhere. And time series data is a series of measurements that occur at regular time intervals. Time, as I said, is the independent variable or predictor. And we try to predict the change in a characteristics or a dependent variable, which could be stock market prices, it could be demand data, it could be sales. And here is our examples: hourly consumption of energy, daily sales, quarterly profits, and so on. Now the time could be daily, monthly, hourly. It depends upon what your time unit interval is, and you could be measuring that. So the goals of time series analysis is to understand the patterns and changes over time. And these patterns have specific names. They're called trend. And trend is a long-term pattern where you're seeing either positive, which is growth, or a decline, or multiple blocks of time periods. So it could be over multiple years. Seasonality or cycle is cyclical patterns that you see within a time period. So it could be within a year you see this constant up during a certain time of the year. Let me give you an example. Between Halloween to New Year, you'll see a huge increase in sales every year. That's seasonality. That's not trend. Okay. And then if you take you take the seasonality and trend out of the picture, there's something called level, which is essentially a flat movement with some irregular movement, up and down movement, which is also called noise sometimes. And level is pretty much a flat structure with some minor fluctuations. So the assumptions we make here are time flows in one direction, so past can influence the future, not the reverse, and events close together in time have stronger associations than more distant observations. So if you're looking at monthly data, last month's data has more impact on this month than last year's data. Finally, remember, and this is important for all of you to remember, is when you do forecasting, you will always have an error. And these errors are random fluctuations in data. You cannot predict them. And they tend to obscure these underlying patterns. And then we'll talk about these smoothing techniques which cancel out and reveal trend and seasonality. So let's talk a little bit about errors because it's very important. And we're going to focus this lecture on dealing with errors first and how to calculate them. Because once you do that, then you can look at the different time series data sets. So any forecast is going to have an error, and you're going to have to measure it. So error is your actual value minus your forecast. So if you forecasted the demand is going to be 5,000, and actual value was 6,000, your error is $1,000 or 1,000 units. So positive error means our forecast is less than your actual value. You underestimated what's going to be there. Negative error means we have overestimated the value. So this is each value there is an error, but you've got to get one value for that entire data set. And so we try to find average error. And so here are some measurements. We have mean square error. So let's talk about what mean square error means. It's basically you take the error and you square it, and you take all the squared errors and you find the average. That's mean squared error. Second one we're going to talk about is root mean squared error. Remember, mean squared error is average squared error. So you take the square root of it, you get average error, and that's root mean squared error. Okay? Mean absolute deviation. This is you take the absolute value of this error term and you average it, you get mean absolute deviation. Root mean squared error and mean absolute deviation both give you average error, but this one's going to be slightly higher than this, and we'll talk about this more. Mean absolute percentage error is you essentially take the absolute error and then you divide it by the actual value to get mean absolute percentage error, or MAPE. All right, so error is actual minus forecast. You have something called a bias, which is the sum of these, actual minus the forecast. When you add them all up, if it's positive bias, that means you are generally tending to underestimate what you're going to get. If it's generally negative, then you're tending to overestimate. You have mean squared error, which is the average squared error, and here is how you calculate it. I'm going to try to avoid mathematical symbols here, but they will come to a point, especially when we get to prescriptive analytics, where I cannot avoid that, and we are going to have to deal with math symbols. Okay, so this is average of the squared error. Root mean squared error is the square root of it, which gives you the average error. Mean absolute deviation is the average error too, but it's the average of the absolute values. And we'll talk a little bit about why we need these two kinds of errors. Mean absolute percentage error is you actually take this absolute value of actual minus forecast, or absolute value of the error, you divide it by the actual, and then that ratio, you find the average of that ratio. Okay, that gives you absolute percentage error. And we'll talk about why you need to mention that. And your tracking signal is your bias divided by your MAD for that time period. So bias tracking signal will tell you whether you're kind of getting too far away from your forecast is really getting far away from the actual, in which case you need to recalculate your forecast. And finally, we'll talk about confidence intervals or prediction intervals, which is your forecast plus or minus your z-score. So, it could be a 95% confidence interval or 99% confidence interval. And then 1.25 times MAD is your standard deviation. So remember, your forecast is your average, and then this is your standard deviation. So you can build a prediction interval or a confidence interval for your forecast and kind of say, here's your upper and lower forecasts. So here's your demand data. I've already given you the demand, and I've already given you the forecast. So now all you have to do is to calculate the error. So the first thing we do is to do a scatter plot. We calculate the different errors. We build a 99% confidence interval and calculate the tracking signal. And then we'll talk about the results. Okay, so let's move on to Excel. So here is Excel, and we're going to calculate error, squared error, absolute error, percentage error. Once we have these, we can then calculate our bias. We can calculate mean squared error, root mean squared error, mean absolute deviation, mean absolute percentage error, tracking signal, and then also our confidence intervals. So let's go through these, and then what I'm going to do is to show you how to calculate these values without going through these steps here. Okay, so let's talk about what error is. Error is your demand minus your forecast. Your squared error is the square of this error. Your absolute error is the absolute value of this error. Your percentage error is your absolute error divided by your demand. Now, before we get into all this, it's very important that you get a right format for your numbers. So numbers, make sure the 1000 separator is there. Use 2 decimal places. If it's percentage, make sure you have the percentage here, right? Make sure, keep your formatting proper, otherwise you're going to struggle using, especially in time series forecast where you have a lot of data. So copy, paste formulas, and go ahead and increase the length of your columns, so that width of your columns, so that you can see what the data is. And now we're going to calculate your bias. So remember, your bias is the sum of this error. And so if you add up all this error, that'll give you the final bias. But what we want is a running total for time period. So we're going to start with saying sum, and then we're going to select error, that's D3, and then you're going to click D3 again, right? And what I want you to do is go to the first D3 and press F4. Make sure there are dollar signs before this D3 and press enter. What this does is when you copy this down, right, and copy formulas, you'll notice that the first value, D3, stays as it is, does not change, but the second value changes as you copy down. So this will give you your total bias here. Now let's look at your mean squared error. You're going to calculate, it's going to be the average of these values, but again, you want a running total. So you're going to say average, and it's going to be E3. And here again, you're going to select E3. Go back here, press F4, and then you have this here. Root mean squared error is the square root of this, right? MAD is going to be the average of your absolute error, that's F3. And make sure this F3 has a dollar sign. MAPE is going to be the average of your percentage error, and that's going to be G3. And then if you go ahead and put a dollar sign right at the start here, and then you press this, and then you put G3 again, sometimes that dollar sign disappears. That's why I do both, and then I do that. So let me give you an example here. You go here, and then you put column, and let's say you select this again. That's funny, it didn't go off this time, but sometimes it does go off again. So you have, these are set up, and you can copy them, the formulas down all the way, right? Always make sure that your formulas are correct by double clicking on them and making sure the correct cells are selected. Notice that this needs a percentage value, and that gives you your values here. So here are the errors. Now we're going to look at the tracking signal and your confidence interval. So let's work through that. All right, with respect to tracking signal, it's very important, especially when you have an MAD. It is your bias divided by your MAD, and if you have a 0 MAD, you're going to get into trouble. It'll give you an error. So you want to put an if function and say if MAD is not equal to 0, right, then it is your bias divided by MAD. Otherwise, it is 0. And that should give you your tracking signal, okay? We can go and copy this down. All right, and that will take care of your tracking signal. Now, before we calculate your confidence interval, I'm going to kind of show you how you can calculate MSE, RMSE, MAD, and MAPE in total. Now, essentially, you should get, these are the final values for that, right? You need to get these values. But do we need to go through these steps all the time? Well, it depends on whether I've asked you to calculate tracking signal or not. So normally what we can do is we can get these values by using special Excel formulas. And I'm going to show you these Excel formulas right now. So here is the manual calculation. So let's start with mean squared error. You can use a function called sum x m y 2. Now remember, when you say sum, you get 3 different formulas. What you don't want sum x2 my2. You don't want some x2 py2, you want some xmy2. Okay, each one of these is actually different. So let's look at sum xmy2. This is sum of array 1, and then so it's sum of the product of. Okay, so the array 1 here, sum xmy2, would be your actual demand, and then you have your forecast. So this basically does this minus this, and then it squares it. This minus this, and then squares it. This minus this, and squares it, right? But you also need to then take the average of it. So you're just going to go ahead and do count. You can count the periods. You can just click 36, but count works pretty well. So that gives you, and let's go ahead and format it. It should give you the same answer you have right here, and it does. So this root mean squared error is the square root of that. Oops, just square root of R3, not R4, and that should take care of that problem. Now MAD. MAD is the absolute error of, again, the difference between the forecast, and it's the average absolute error. So let's take a look at that. All right, so now you're going to find, you say average, and then you take absolute, and then you select the first row minus the second column, sorry, first column minus second column. And what this does is it takes each value, subtracted from the other value in the other column, and then it takes the absolute value and then it averages it out. And make sure you close both parentheses. That should give you 798.03. So similarly, now you can do the same thing for your absolute percentage error. And let me go ahead and, there you go. So here what I'm going to do is I'm going to say average, and I'm going to start with the absolute value, right? We are going to take this minus this, and then these should be, before these should be divided by your actual value here, right? And then you close the brackets. So let's see whether this works. And here is your 10.08, and you got that. So you notice that we take the absolute difference for each value, and then you divide it by the actual values here, and then you take the average, and it'll do it automatically. So these are the formulas you can use to calculate these values. Once you have the MAD, you can calculate your lower confidence level and upper confidence level. So let's get into this confidence intervals one more time before we start calculating it. I want to show you what confidence interval is. So you've already done that, but I want to kind of do it one more time. So here, when you're looking at a normal distribution, the confidence interval comes here, 99%, which means 1% is on both sides. And if you divided it by 2, this is 0.5%, and this is 0.5%. Therefore, you're going to get the z-score for 0.5% and for 99.5%. Okay? I hope all of you understand that. So let's start working on that. So we are going to do your forecast plus norm.s.inv 0.005, which is 0.5%, multiplied by 1.25, multiplied by your MAD. Make sure you put an F4 that it's pinned down. And here you're going to put forecast plus norm.s.inv, and now we're going to look at 0.995 multiplied by 1.25 multiplied by your MAD F4 here, and now you can copy these completely down. All right, so this should take care of that. Now, a lot of times when you're doing big Excel spreadsheets and you're going to see it in forecasting, sometimes you'll find that your calculations do not change. They seem to get stuck. So you can go to you can go to formulas and click for calculate now or calculate sheets, and that will make that unstuck. So this kind of takes care of your calculations. I will show you later on how to visualize your data, how to draw graphs for your forecast. We'll talk about all that. But right now I just wanted to focus on the error terms and how you're going to calculate those error terms. So back to PowerPoint, and let's go take a look at the solution. So we have built our forecast. We already had the forecast. So here is actual demand, here's the forecast, and we kind of built our upper and lower confidence level intervals. And let me talk a little bit in Excel and show you how we can build these graphs. So let's go to Excel and go back to Excel, and then let's look at how we're going to build these graphs. Okay, so this is the demand and the forecast and the confidence intervals. And you need to insert, we're going to insert, I'm just going to select the period, demand, and forecast. We're going to insert your scatter plot right here. You can use, of course, the scatter plot, but this doesn't give you a good picture. Don't use the continuous smooth lines and markers. Use the jagged lines and markers, okay? And then you can go here and you can select two more sets of data, series name of lower control limit, and your Y, this is your lower value, and you can also add upper control limit. This is your upper value. And a lot of times what I do is I move these up to get the lower control forecast, and then finally I show the demand sitting on top. Especially when you copy and paste this into PowerPoint, you can then get them to come appear by series with the animation, and that makes it very, very useful. Also, I like to, if you right click on these lines, you can change the color. You can make sure that I like to use the control limits in dashes. It's completely up to you, but some amount of formatting would be useful as you present your data. So this will kind of show, and you can see right here that your demand point at time period 10 almost reaches your upper control 99% confidence level limits. Okay, so this is essentially how you present your data on the chart. So you can copy and paste the chart you created from Excel onto your PowerPoint. You can, here's the demand, here's the forecast, and here are the upper and lower control limits. So you can create it that way, and you see that the animation, each one kind of comes separately, and that makes it easy to present. So we know that trend, and I've talked about this, is a long-term upward or downward pattern over multiple years. Seasonality is cyclical, which is predictable by seasons or time of the year, and we are going to discuss multiplicative or additive seasonality later on in this session. And then finally level. When you remove trend and seasonality, you see some minor fluctuations, but it's mostly a flat line, and that's basically level. So as you can see here, you can see kind of a positive trend, then it kind of moves down, then goes up, and then goes down again. So if you kind of take the ups and downs, you can kind of see it's smoothed out here. And then if you look at, this is the trend, so you can see it going up, down, then up again. So right, but it's over multiple years. Here's some seasonal factors where it consistently keeps going down at some time, and then here's the remainder of it, which is just minor fluctuations. So here is data for the Chick-fil-A sandwich from April 12th till April 18th, about 6 years of data. And here is your demand data, right? And when you present your data like this, it may not, you may not be able to see the complete picture. Of course, you can see kind of a trend, but it's hard to tease out seasonality. But you can present data and break it up year by year. So let's look at 2012 data from 1 to 12, from January to December 2012 data. And you can see I have essentially I have data from this is September, October, November, December. So it doesn't tell you much. Here is 2013, and you can see kind of flat, and it jumps up in October. Chick-fil-A sandwich, people seem to buy a little bit more in October. Again, the same thing in 2014 with a slightly positive trend. And again, 2015, there's a jump. Again, October, there's a jump, and in December, there's a jump. You can see that here also. There's a slight jump in December. Similarly, in 2016, again, Chick-fil-A sandwich, and you can see here December jump, October jump is there, but December jump is even higher, and then you can start seeing some more. But definitely October and December, there is some jump. And here's 2017 data where we've got only up to August, right? But this kind of gives you a general idea of seasonality. You can actually start looking at the data and seeing how to visualize the data. So with this, we're going to stop this lecture. In the next lecture, we're going to talk about very simple forecasting models. These are by using level methods. We're going to try and reduce and flatten the errors, try to tease out a pattern, and we're going to look at simple moving average, weighted moving average, and exponential smoothing. I hope you enjoyed this lecture. Try to practice calculating your errors, and I will see you in the next lecture.